Hello, my name is Pranshu from Group 20 and I will be presenting our dataset, project goals and dataset analysis for fungal infection diagnosis through deep learning. Firstly, our project is presented by Group 20 consisting of 3 members, myself Pranshu, Mansher and Ravi. In this presentation, we will be presenting our introduction to our project and its goal, followed by several pre-processing steps and analysis of our dataset. The driving force behind our project stems from the widespread incidence of mucormycosis during the COVID-19 pandemic. Our goal is to develop a model which can be used to provide a safe and effective initial treatment by facilitating early detection in the diagnostic process. Conventionally, the diagnostics and the treatment of fungal infection in human is heavily been dependent on consultations with mycologists, with most of the machine learning models being utilized during the later stages. However, we aim to develop a model by harnessing the capabilities of deep learning techniques to enable early fungal detection. Next, we will be looking at some of our pre-processing steps as well as the analysis of the dataset. We are developing a project using Google Colab to have better collaboration and peer review amongst the team members. And we have stored dataset in a shared Google Drive location to enable faster upload time of the dataset. Our project uses a dataset curated by LEM, a mucologist laboratory situated in Bogota, Colombia, and comprises of labeled images with manual annotations and automated cropping and patching using programs. The label assigned to these images fall under H1, H2, H3, H5, and H6, where each of these labels are associated with the class of the fungus as shown in the slide above. Firstly, we display the various images from the dataset using matplotlib subplots from the classes for the classes as shown in the slide. We notice that the microscopic images tends to be noisy and thus might require image denoising, for which we have used scikit-learn implementation for non-local mean denoising algorithm to remove the noise while preserving the image texture. After removing the noise from the image, we render the images again and observe an improvement in the image quality. We analyze the image using the pair plot of color histogram to check the mean color distribution and check whether the dataset is balanced or not. We also analyze the image size to ensure that all images are of comparable quality and the size is able to produce results in the respectable amount of time. From the pair plot, we can observe that the two fungus, namely Candida albicans and Asparagus niger, have higher color mean than others, hinting that the dataset might not be balanced. From the image size comparison, we can see that the images are of roughly same quality. However, it might take longer to train model. Thus, image resizing is performed to get results in a reasonable amount of time. To remove dataset imbalance, we can either reduce the sample datasets or create new data from already present data using image augmentation. The latter step is preferred due to fewer labels and the sample sizes. Adding more data into the dataset stabilizes the data set and make it less likely to overfit. Image augmentation is a process of creating new images from an already present image and is only performed for the label if necessary. Here are the results from the data imbalance due to large size differences amongst the classes, as we can see in the slide above. The augmented images are stored in separate folders with the similar folder structure before merging with the original dataset. After augmentation, it can be noted that the dataset is balanced. The original images are large and thus might require high computation power, memory, and training time. The images are resized to produce the results within the reasonable amount of time and with reasonable resources. The original image has 500 dimensions and have been resized to 224 dimensions using OpenCV. To conclude, we have presented our database and its analysis with pre-processing steps performed on the dataset by rendering the sample images, removing noise from the dataset, checking if the image sample size is imbalanced, and fixing it using image augmentation for the labels if necessary. Lastly, we have performed image resizing to train the model within the reasonable amount of resources and time. These are our references used in our presentation. Thank you.